Yep. Okay, good. So I'm gonna start recording. So that is one announcement to make, which I just sent out an email to everyone that starting this Wednesday, which is 11 November the 3rd, we'll be meeting back in BHCC 108, back in classroom. So it's the same, so it's from 4:30 to 6, 5:55, around that 5. So it'll be real meeting in the classroom. Bring your laptop, or if you don't have a laptop, you can borrow it from the school. So again, starting from this Wednesday, we'll meet back resume back in meeting in BHCC 108. Anyone have any questions with that one? Okay, so that's first announcement. So we're gonna meet back in BHCC 108 every Wednesday. Second thing is homework. Anyone have any homework on 7.2? Because we just started 8.1. So anyone have any homework questions on 7.2? 7.2 and 8.1 is due this Wednesday. Anyone on 7.2 homework? Anyone have
do.
Yes.
I do, but
Yep, Casey.
Hold on, let me log into my lab.
Yeah, you guys have to log in because we are using my StatCrunch too, so make sure.
I think I'm not understanding how to use the my StatCrunch part of it.
What do you mean by my StatCrunch?
Here, let me see.
Anyone have any questions for me besides Casey's? Again, 7.2 and 8.1 is due this Wednesday.
Okay, so for like question 4, so it's asking me to construct a confidence level, and then it gives me, like it wants me to find like the critical value for this, and then the critical value for
asking
Z.
to find a critical value. Yep. So
but I'm lost.
So in order for you to find the critical value, which is the first example that we did here, so you have to figure out, are they neither first? Neither means the population is skewed and the sample size is small. And then if it's not neither, then it's either Z or T. So if sigma is known, it's Z. Sigma is not known, is T. If you are Z, you're using normal calculator. If you are using T, you will use the T calculator. So for example, is question number 4 is given us that here is assuming that we want to construct a confidence interval, finding the critical value, is that T or Z, or is that neither normal nor not stated as neither not normal or not. Here's a summary statistics. It's a random selected girls with N is 264 and X bar is 33.3, S is 6.9, and the confidence level is 95%. So the sample size is big here. See that? So it's not neither. So it's not this one. This is not this one because the sample size is big. And then the other thing is figure out if sigma is known or sigma is not known. So this question, they provide us S. So S in this case means sigma is not known. Okay, so if a question provides us S, means sigma is not known. Okay, so in this case, so sigma is not known, so we're gonna use the T calculator. So you have using T alpha over 2 in this case.
Wait, but I thought sigma was known because it gave you.
S and sigma are 2 different things.
Oh.
This is S, not sigma. Sigma looks like It looks like that this little 6 in there. This is called sigma. There are two different symbols. So the
I thought they were the same. Okay.
Nope. So we have two symbols, S and sigma. S is for sample standard deviation. And this is the population standard deviation. And there are two different things. So since the question here only provide S, not sigma. If this is sigma, then we will pick Z. And if they use S, we will pick T. And how do we calculate this? Is the 95% confidence level. So that means that our alpha in this case is 5%. Our N in this case is 264. So you have to go to your T calculator in your stat crunch. So you go to stats calculator, T calculator. And the first thing they'll ask you to put in down is the degree of freedom. And the degree of freedom is N-1. So it's 263. So it's 263. And then you change it to greater than. And then you blank this follow up. And then you take 0.5 over 2. So this is how you use your T calculator. Your degree of freedom in this case is N-1, so it's 263. And then you do Px greater than or equals to, make sure you blank this, that is your answer you're looking for. And then you take 0.05 divided by 2, alpha over 2. And when you hit compute, 1.969, that is your answer.
Okay, thank you.
Then they put in there. Yep. In 2 decimal place, 1.97. Yep. So that's how you find your answer. So make sure you know that S means be using T. And not this. They don't have it. Yep. So yeah, make sure this is. So this is the one that we're using. I thought I should assign more. This is the only one I assign. Okay. Thought I assigned more than one. Anyone have any questions for me? This is 7.2, and we're gonna go 8.1. We're still just starting 8.1. And if you do have questions, let me know, and I will definitely help you. So we're gonna talk about 8.1 here. So as you know that we are doing what we call as a hypothesis testing in chapter 8.1, which is a 7 steps procedure. And I teach you the first step. So the first step is called the first step is requirement check. So we will kind of skip it in this section. So because we will do the requirement check when we go through 8.2 and 8.3. So for 8.1, we just assume all the requirements are met. So that means we can skip it. So step 2 is where we do your hypothesis statement. So we got 2 types of hypothesis statements, the null hypothesis and the alternative hypothesis. The null hypothesis is where the population parameter is equal to a claim value. That means there's no change, no effects, or no difference. The alternative hypothesis we all denote as HA is a parameter that is somewhat different from the claim value. We always use less than, greater than, or not equals to. So if you look at your hypothesis, how we write it, the H0, we use P to symbol proportion, okay? And we use the mu to symbol as mean, okay? So we got 2 types of population parameter here. So P in this case for proportion, population proportion. This is where you will get in 8.2. So when you do your online or your homework 8.2 is all about proportion. So we will use the P symbol. Okay, the mu symbol, like the one that you see over there, this means population mean. This is used in 8.3. Okay, so just make sure that you guys know that the difference between proportion and mean. Make sure you read the question really, really carefully and figure out if the population proportion P is used or the population mean mu is used. And the number behind it, the 0.5 and the 1.1234.5, this is called the claim value. Okay, the 0.5 or the 123.4. This is what we call as the claim value. And this is always stated in the claims question, in the claim question. So that means that when there is a question, they always say this is the claim statement. It is less than 50%. So less than 50% is what we are talking about here. And when you do your the null hypothesis is always equals to 50%. So the null is always equal. The alternative can be less than, greater than, or not equals to, depends on your questions. So for the first one, if you look at this, it was your claim statement in this case was saying that the proportion is less than 50%. And that is what is the meaning of, so when you have your claim is a proportion is less than 50%, then you will get the statement looks like this: H0 P is equals to 0.5. HA P in this case is less than 0.5. So this is what your claim will looks like. Okay. If you want this, then the claim statement will say the mean is equal to 123.4. So that is the claim statement. The mean is equal to 123.4. So when you have the equal, so the H0 in this case is where the mu is equals to 123.4, but your alternative hypothesis HA, mu is not equal. So this is because I don't have a not equal symbol here. So I'm going to use that symbol for not equals for 123.4. So which is this symbol. Okay. So you notice that the claim value has to be the same, 123.4 and or 0.5, depends on it. And the word less than, that's where you put less than symbol. And if a question uses the word equal to, we are testing equal with not equal to. Okay, so this is the statement we do. So we got called a left tail test, right tail test, and a two tail test. So a left tail test is where you have this kind of symbol, less than. So this is called a left tail test. Okay, this you use not equals to. This is called a two tail test. Okay, so let's see some examples so you guys know what I'm talking about here. Okay, so so the first example is asking us to write the null and the alternative hypothesis, and then make subjective estimate. So kind of make estimate whether the results are significantly low or significantly high, then state the conclusion about the original claim. So when I say significantly low or significantly high means are they on the lower side or they're on the higher side? This significantly low or significantly high is based on the results. Okay, so they give us and usually the results which is comes from poll or comes from come from polling station or come from experiment or come from it's a result from someone did it. Okay, that means it comes from a poll, or in other words, it comes from the sample. Okay, so so example is if you read the first question, that is the claim. So that is very important. So this is the claim statement because it has the word claim on it. Okay, and then the other one is the results. In the pool of this 87 people have. So this is used to make your conclusion. Either it's significantly low or significantly high is based on the results. So first we have to write the hypothesis statements. So can someone tell me if I give this fewer than 95% of adults have a cell phone, is this talking about mean or is this talking about proportion. And I use this.
Proportion.
This is talking about P, proportion, because the reason why this is proportion is anyone?
Percentage.
There is
The
a
decimal.
percentage. And this is proportion is also used for categorical variable. So if you read this, it says that either you have a cell phone or you don't have a cell phone. So either yes or no. So it's a categorical type. Okay, so that means we're gonna use P. So can someone write this in like an inequality? Fewer than 95%. So what symbol should we use for this fewer than 95%?
Less than.
So in this case, you have two statements when you write your one is a null statement, and one is your alternative hypothesis. And since you told me is proportion, so we're gonna use P. If it's mean, we use mu. And as you say, fewer means less than. So if you have less than, greater than, or not equals, we always put them in the HA, the alternative, and 95%. So this is how we write fewer than 95% have a cell phone. You put it in the HA, the alternative, where P is less than 0.95. For the null hypothesis, is always equals to 0.95. So this is how we write your null and your alternative hypothesis. Okay, so make sure you understand the null is always have an equal symbol. The alternative is either less than, greater than, or not equal to symbol, depends on the question, the claim question. Okay. And now we look at the result. So out of this 1,028 adults, 87% say they have a cell phone. Okay, so is this 87% are they meet this fewer than 95% adults?
Yes, they do.
So they meet, right? Because 87% is fewer. So this 87% is what we call as significantly, is no significant. The reason why this is no significant is because the 95%, because 87% is less than 95%. Okay, so that's why we call it as no significant. So if I kind of draw the picture in this case, okay, so 95% is here, and less than means is here. So if your number falls inside this range, this is called no significant. If your number falls in this range, this is called significantly high. Okay, this is called significantly high. Okay, this one has no significantly low. The reason why there's no significantly low is because it's only one-sided. So 87 is right over here. This is somewhere around 87%. That's the reason why that this is no significant in this case. Okay, Lawrence, I'm going to reach you a little bit here. So then you have to state the conclusion. So the conclusion is, since 87 is fewer than 95%, so the conclusion support the claim. So the conclusion is very easy. Is either you support it, or you does not support it, or you reject the claim. You use the word reject. So how do we know we support or reject this number? So 87 is fewer than 95%. So you support the claim in this case. Okay, so this is how we kind of, again, this is kind of how we write our conclusion here. Very simple, based on the results that you get. Anyone have any questions here? Okay. Read question number 2. There is a claim statement. The claim statement says that the mean pulse rate of adult male is equal to 69 beats per minute. 69 beats per minute. So this is the claim statement. So as usual, the first thing we talk about here is this proportion or is this mean?
Mean.
So this is mean, because the question is using the word mean. Okay. So how do we write this in terms of the null and your alternative hypothesis? Anyone? So we're gonna use mu here. The reason why we're using mu is we are using mean here. So we're gonna use mu in this case. So can someone tell me how do we write this equal to 69 BPM? Where do you put this? Should we put this in H0? Should we put this in HA? Equal to, and don't forget, H0 is always what symbol?
Oh yeah.
And HA is always what symbol? So what do you put equal to 69? H0 or HA? Anyone? Grace?
Isn't it H0?
Yep. So again, class, H0 is always equal to something wrong with my, what happens to my, so it's 69 BPM. So what will be the H1 in this case, HA in this case? So if a question is using equal, are we using less than? Are we using greater than? Or are we using not equals to? So as I mentioned here, if you have equal to, what is the HA that we use? We always use what? Not equal to, yes. So in this case, that so if a question is using equal, we will be using not equal to. Okay. Oh my God, something happens to my, there you go. Not equals to 69 beats per minute. So so this is how we write your hypothesis statement. So always remember that your H0 have the equal symbol. Okay. And your HA have the less than or greater than or not equal to symbol. One of this. Okay, one of the symbols. Okay. And 69 is always even in this called 69 in this case called a claim statement. Okay. So what happens to this case if I draw the picture? So because last time this is a left tilt, yeah, this is 95%. This is a wrong picture. It's supposed to be wrong. I am so sorry. This is number one, not supposed like that because this is number one supposed to be look something like this, 95%. And less than means it's on the left side. Yep. So this means this is still significant. Yep. Same thing actually. Yeah, I'm sorry. This is no significant. And this is significantly high. Okay. Now for question 2, this is question 1, looks like the picture. For question 2, you got two-sided. So what happens? Why I say it's a two-sided is because there is no equal symbol. So so you will have two-sided here. Okay, and 69 is right in the mean, right in the middle. So remember, mean is always right in the middle. So it's 69 here. Okay. So now we find out the results. The results in this case is 69.6. So where is 69.6 in this case? Is that on the low end or is that on the high end? 69.6.
High end.
So it's on the high end, so somewhere around here, 69.6. So in this case, 69.6, because you're looking for the mean. So 69.6 is in the high, significantly high. Significantly high, because it is greater, right? It's on, so this is on a significantly high because it is higher, right? 69.6 is higher than 69. Okay. So this is first thing they ask you, are they significantly high or low or no significance? So since this is higher than 69, so it is significantly high. Then we ask, is 69.6, is that equal to 69? 69.6, is that equal to 69? So this is your claim. So do you support your claim or do you reject the claim? Is this number equal to 69?
Reject.
So in this case, we will reject the claim because 69.6 is not equal to 69, right? So in order for us to support the claim, this number should be exact the same as 69. Yes, Casey.
So there's no like a different, like a percentage difference. It has to be exactly.
In this example, it has to be exactly. But then later on, we will use the real way to calculate.
Ah, Jesus. Okay.
So again, this is just for 8.1 because I'm not really concentrate more on 8.1, Casey. I'm more concentrate on 8.2 and 8.3. So if you're stuck in 8.1, well, don't worry about that because 8.2, 8.3 is what we are concentrate on. So my main goal for this 8.1 is make sure you know how to write your claim. But I don't really care about this conclusion because you will make the correct conclusions later on. So what happens in 8.1 is I told you there are 7 steps to make a hypothesis testing, right? So 8.2 and 8.3, we combine all these 7 steps into one big page, one long page. But in this section, they kind of break it down into 7 sections. The first one is how you write your statements, and then the second one is how to do this. So they break this into 7 pieces. And then after that, in the next 2 sections, they will combine these 7 pieces into one big page. So the reason why I'm teaching you this is because in your multiple choice, I cannot come up 7 pieces like this. It's really long. So I will break it down into like small sections. Example is like, I give you this claim statements. I want you to give me the hypothesis statements. Which one is the correct hypothesis statements? So you just need to pick up the correct one in this case. Okay, so they just break it down into 7 pieces. Okay. So that is the first thing you need to know, class, is to figure out how to write your hypothesis statements, the null and your alternative. After that, you will see a better idea why I'm doing all this into one bit. Next, we're going to talk about is test statistic. So what is a test statistic? A test statistic is a value to decide whether what you do with the null hypothesis. So what is the decision that we have here is either you accept or you reject. That's the same conclusion we did. So what happens to the test statistic depends on your proportion or mean. If you have proportion, the test statistic in this case is called a Z. If you are using a mean, the test statistic is called a T. Okay, so a test statistic is given as either Z score or a T score, depends on what we are using or what we are doing. So that's why proportion we use Z, mean we use T in this case. And this test statistic is found. This is given in StatCrunch. So if you look at your online homework and you say, help me to solve this to find the test statistic, they give you a very long formulas to figure it out. You do not need to worry about it because your StatCrunch will give it to you. Okay. So I will tell you what is all this is. Then we have a significant level, alpha. So this alpha is what we'll be talking about since chapter 7. So if you remember, we are doing a 95%, the one that we just did in chapter 7.2. The alpha that we figure out here, this is coming from the 95% confidence level, right? This is what you did in chapter 7. So this alpha, now we have a name for this alpha. We call that as your significance level. Okay, so this alpha is called significance level, is the probability of a cutoff a value that used to cut off to determine that are you rejecting or are we accepting the null hypothesis. Okay, so this we call it alpha, is a probability. And then the region that you shade is called the rejection region, or that we call it critical region. This is the area correspond to the value in the test statistic that cause us to reject the null hypothesis. Okay, it depends, either it's a two-tail, left tail, or right tail. I'll give you an example of it. And then this is the last one, critical value. Critical value is the value that separate the critical region from either you reject or you do not reject. So how do you find the critical value? Let me finish this and I'll show you what all this means. In order for you to find the critical value, is right over here. So this one is super important. Some homework wants you to find critical values. This is how you find this critical value. We did it before on this. So remember how we find critical value that Casey asked me early on, like the mean. So this is the one that we talk about. So when you do the mean, we will be using the T calculators. And then you put the degree of freedom is n-1 and then x greater than equals to blank and then alpha over 2. This is used when we have a two-tailed test. Okay, so this is used when we have a two-tailed test. So for two-tailed tests means not equals to. If it's a mean, we use a T calculator. Make sure you put alpha over 2. If it's a left-tailed test, then make sure that you change the symbol to become less than, because left-tailed test is on the left. And if you this is only have alpha on it. Okay, a right-tailed test, you use the greater symbol, and then this is only alpha. The only thing that you take alpha over 2 is when you have a two-tailed test. Okay, so when you have a two-tailed test, we will be using alpha over 2. So this is for mean. If you are using proportion, which is a Z, then we will not using T calculators. We will using normal calculators. If it's a two-tailed test, we use greater than and then alpha over 2. If it's a left-tailed test, less than with an alpha. If it's a greater than right-tailed test, is greater than and an alpha. So this is something I will teach you how to do it. So let me show you what we do here so you guys know what I'm talking about here. So this one is 8.1. Yeah, this material is very difficult. I would suggest you to read your textbook for chapter 8.1. So let me show you what all this means. So if I asking you for a 95% that last time confidence interval, so our alpha in this case is 5%. So this is what we call as significant level. Now we have a name for that. Last time we call it error. So now we call it significant level. Now, as you know that we got 3 types of tests. We got a left tilt test. So what happens when you have a left tilt test? Your critical region or your rejection region is on the left side. So you always draw this line. This line is called the critical value. Okay, and the shading part that we have on this is called as your rejection region. Okay, or we call it as your critical region or rejection region, which is an area on, if it's a left tilt, is on the left side. Okay, this critical value is found using this, either x greater than or equals to alpha. So this is found x less than or equals to blank alpha. And again, alpha, if it's 95%, then alpha is 0.05. Okay, so this is called the left tilt. If you have a right tilt in this case, it will be on the other side. So your critical value will be on this side. Your critical region or your rejection region is going to be on the right side. And in order for you to find this critical value, you go to px greater than or equals to blank, and this is equals to alpha. It depends, again, if you are using a proportion, we do normal calculator. If you're doing mean, we're using t calculator. Okay, so same thing happens to the left, same thing on this side. Proportion, you use normal, t mean, you use t. And then the last one is a two-tilt test. So a two-tilt test is for a not equal symbol, means that now your critical value will consist of two. So you got two critical value and you will have two-sided. So that means you got two rejection region here. Okay, this is all rejection region. So that's the reason why when you do, in order for you to calculate this, you have to take px greater than or equals to blank, and you have to use alpha over 2. That's why when you look at the two-tilt test for the critical value, they all have alpha over 2 next to it. The reason why is because you divide this into two-sided, and your answer for this is one is negative and one is positive. So make sure you understand this, that this answer has positive and negative. Okay. For the right tail, your answer in this case is always positive. The reason why is because the area is don't forget, this is 0. That means your critical value is always on the positive. And if you go for the left tail, again, this is 0, your answer for this is always negative. Okay. But when you look for the two tails, your answer is plus minus. But when you do it in your StatCrunch, StatCrunch only gives you the positive answer. So when you write in your homework, make sure you put it plus minus. So this is how you find the meaning of a critical region, and it depends on left tail, right tail, or two tail. And when I say the 5% is this. So this is all 5%, the one that is shaded. That means this whole thing is going to be 95%. So everything from here to there is 95%. Same thing happens is on the right tail. This is a 5% here on the right side. So everything on the left side is 95%. For a two tail, this fellow has to be divided by 2. So that's why this is 5% divided by 2. That's why we use alpha divided by 2 here. So that means that in the middle is the 95%. So this is what we do a lot in chapter 7. Yes, Casey.
So where you have the answer where it's like px, greater than or equal to, is it always that symbol?
Depends on, for two tail, we always use greater than.
Always greater than, okay.
Two tails is greater than. Right tail is also greater than. The only time that we use less than is when we have a left tail.
Yep, thank you.
So we only use this for the left tail. Okay. So this is what we call as critical value. Okay. So what is a test statistic? A test statistic is a number, a value that either we are rejecting or we are accepting. So don't forget the one that I shaded, or I shaded in the area there, the rejection is rejecting. So this is accepting. So so this is reject, this is accept. So 5% reject, 95% accept. Same thing here. 5% reject, 95% accept in here.
So hello, Prof.
Mhm.
So how do we know in the question if it's a right side test, left side test, or
It's
two-tailed
like what
test?
we just did in the example here. They will give you a claim statement.
Okay.
So if we use fewer, then this is a left tilt test. This is a left tilt because it's using less than. You see that? This is a two-tailed test.
If it's greater than, it's going to be either a two-tailed test or a left-tailed test.
Fewer is left tail. Equal is a two-tail. Greater than means right tail.
Okay.
It will in a claim, it will stay in a claim statement.
Okay. Thank you.
Mhm. So you have to figure out which one we use. So that is what we call as your critical values. Okay. So make sure that how do we know left, right, two tails? It is in the statement. So it's in your claim statement. So your claim statement will tell us, are they less than, are they greater than, or are they equal? This is equal. Okay, so equal, we use two tails. Greater than means right tail. Less than means it's left tail. Okay, so now so this is one way to do this is looking for the test statistic. So if your test statistic falls inside this area, if your value falls inside here, we are accepting it. But if your test statistic falls in the rejection region, then we will reject the null hypothesis. So the test statistic is to determine where the number falls in the in this cutoff value. So if it's fall on the rejection area, then you will be reject. If it falls in the accepting, then you will accept your null hypothesis. So depends on your critical value and depends on what your test statistic is. Okay. So again, we are not really concentrate much about this. I'm just teaching you how we perform a hypothesis testing here. So this is one way to do it, which is a lot of work. There is also another way we can do this. It's called the p-value. So the p-value is the probability of getting a test statistic to the extreme as one can represent the data, assuming that null hypothesis is true. So what is a p-value? It's a probability that to get this test statistic to the very extreme as we can. So another way that I can tell you about p-value in this class is, let's say I got a deck of cards, okay? And I want you to figure out what is the probability of you getting a red card. You know, a deck of cards has is 50-50, 26 red and 26 black cards, right? So I give you a card and I say, okay, now Casey, can you randomly pick a card, and what is the chances of this will be a red card? So Casey pick a card from this 52 cards and it came out black. Now that is not shocking to her because it's 50-50 chance, right? So it's not what we call as the probability is not extreme enough. Then I go to Grace. I say, okay, then she keep it. Then I go, Grace. Grace, can you pick another card from this 51? Because now, you know, one card is gone. And what is red to get a red card? So Grace pick another card randomly from the 51 and it came out black again. So now we got 2 black cards in a row. And then I go to Lawrence. Lawrence, go pick. Now I got 50 cards here. I want you to pick. And he picked, and it is also red. So now, oh, it's so black. Sorry, it's so black. So now 3 in a row. 3 students pick this card. Is black cards. I want it red. Okay. And then I keep on doing this. I go to Christina. Christina did it. It's also black. Okay, so 4 blacks in a row. Now I go to Anna, Anna pick it up, and she also picked black. So now I got 5 black in a row. So at what point you think that this deck of cards is rigged? That means it's, you know, David put all black cards in here, no red cards. What do you? So that probability, or that mental, or that something we call it, is called a p-value, the probability to the extreme case. So 5 cards in a row. Some of you might say, you know, 5 cards in a row, because it's half and half, 26 for black and red. So 5 cards in a row to get black. You think that I think it can happen. It's not that extreme yet. Extreme is rare. So if I keep on doing it like till like what 10 times, then you begin to figure out, I think I know this is already 10 times in a row and it's still black cards. I don't see any more red. I mean, you get to get a little bit of like, you know, guessing yourself now. It's like, I think David play a trick on us. I think there's no black cards. There's no red cards. It's all going to be black cards. So at that point, you just say, David, stop. You do not need to. We do not need to draw any more cards because the whole deck is black. There's no red cards. That is the time we call it. The probability is at the most extreme case, or very till one point is, you know, till it's like, you know, super, you know, that you do not do it. That time is what we call as the p-value, the probability. So for us, there is a way for us to calculate this. So for us to calculate this p-value, so it depends again, either we use proportion or we use mean. Or is that a two tail? Is that a left tail or right tail? So for us, if it's a proportion, we use normal calculators. We put p equal x, so px greater than equals to the z-score. So the z-score usually is given in the questions. So in this case, z-score is given in the question. And then you leave this blank. Okay, make sure you leave this blank. Okay, so and then in your StatCrunch, you just type in x is greater than or equals to the z-score, which is given the question, and leave it blank. And for the two-tailed test, you have to double it. The reason why you need to double this is because if you look at your two-tailed test, it is on both sides. So what you're finding here is just this area here. Don't forget, we're looking for area here. So if you want to find the other area, this area is the same area. So that's the reason why we are doubling your answer here, is because you have two-sided. Okay. So for the left tail, we don't use greater than, we use less than. But the rest of them we use greater than. This is for proportion. For mean, we will use the T calculators. Okay, change color here. So we're going to use T calculators. And again, we'll leave all this blank on this side. And we have also to be double this if it's a two-tailed test. Then if it's a left-tailed test, we use less than. And as usual, the T-score will be given in the question. So so this is very important. So especially the critical value. So if you do your homework that asks you to find critical values, I would recommend you to refer to this box or this table. Okay, and I'll show you how to do this now. Okay, I'll look at some examples. So this is example 3 and 4. You have to identify if this a two-tail, left tail, or right tail. Find the critical value and find the p-value, and then assuming then we make a decision. So we'll talk about the decision later on. So let's figure out, are we having left tail or right tail or two tail is the claim statement. So if you look at question 3, do we have a claim statement here? Question 3. We have a claim statement. And where is a claim statement? Usually we highlight the claim statement. Remember, this is a claim statement we highlight. So anyone, question 3, where's the claim statement? The claim statement is right over here. That's the claim statement. Okay, so we always highlight this one. So can someone tell me, this is your claim statement. Is this a two tail, a left tail, or a right tail?
Two tail.
Two tail is when you have what claim statements? A claim statement use the word what?
Equal.
Equal. And if it's a left tail, what is a claim statement use?
I'm left.
Fewer or less than. So what is the, this is what symbol we use. This is a greater than symbol. So what kind of tails is that? This is not two tail. This symbol is a right tail
Right
test.
tail.
Yep. This is a right tail test because the symbol we use is greater. Okay. So how do we find the critical value if your alpha is 0.05? So now we look at your table upstairs. So first tell me, is this proportion or is this mean? So which one is this one? Proportion or mean? Grace?
Wouldn't it be a proportion because it's it's 0.5?
That's kind of proportion is correct, not because of 0.5, it's because the letter P that we use here. You see that? Okay, so P, it stands for proportion, mu stands for mean. So if you see me using P on it, it means proportion. So now we need to find the critical value in this case. Shortcut is CV for critical value. So you say it's proportion and right tail. So if you look at this, so this is finding critical value. We are looking for proportion. This is the proportion. And you say it's a right tail. This is a right tail. So what happens in your StatCrunch? You have to go to normal calculators and you're gonna do P x greater equals to blank equals to alpha. So this is your the right tail test that we have, and it's a proportion. So what we do here is we have to use a normal calculator. Okay, and then we're gonna do Px greater than or equals to blank. Blank will be your answer here, and this is equals to alpha. And what is alpha in this case? Alpha is in the question. Anyone?
0.05.
Yep, right on top here. This is your alpha. Okay, so we're gonna use 0.05 here. So we're gonna take 0.05. So using your StatCrunch, you go to your normal calculator. So we're not using this. So we're gonna use the normal calculator. Mean is 0, standard deviation is 1, the same. And then we use Px is greater than, this is 0.05. Don't divide by 2 because it's not two tails. Two tails you divide by 2. So that means that this is your 5% and this will be your 95%. So this is the meaning of something like what we draw on this side, this right tail. So your answer is here. So the critical value that you have in this case is what? 1.645. So this is a critical value. So the critical value in this case, which is the blank that you figure out. So your critical value in this case is 1.64. Anyone? Questions? Now we need to find the p-value. So in order for you to figure out p-value, we go back to the second table. So this is finding critical value. This is finding p-value. And again, this is proportion. and we are using normal calculators, and this is still right till, so we're gonna put x greater than or equals to z-score equals to blank. Okay, so in this case, we're still gonna use, so we are finding p-value. So I'm gonna change color here. So we still use the normal calculator here. But this time we're gonna take px greater than or equals to. Now, what is the z-score, right? If you look carefully here, it says the z-score is given in the question. So if you look at here, what is your z-score? The z-score is what?
2 point.
Exactly 2. So that is your z-score, and equals to blank. Okay, so that is your answer. That is your p-value here. So now what you do here is you go to your StatCrunch. We're still using normal calculator, which is this one, still 0, 1. Now we will put 2 in here. The 2 comes from the z-score given to us, and then you hit compute. So what is your p-value? My p-value in this case is 0.02275. So my p-value in this case, I just used p-value, which is the blank, the one that blank here, 0.0 something, 2 something, 0.0228. So this is the blank. So whatever the blank that they use, so this is the answer. You guys all right? Questions?
Do we need to draw the?
Nope. But if you want to draw, you can, but the picture will look very similar to this picture. And the main part when you guys do this in the test or in my homework, make sure you know that this is a right tilt test. So all the shading is on the right side. So if you find out your shading is on the left, or your shading is in the 2 of them in between, like 2 shadings here, you will get it wrong. Okay, so because this is a right tilt test.
Can you scroll back up all the way to where you had the right
Table.
there?
Mhm.
Yeah.
And Casey, the one that I sent, the bad one is very different from this one. So I hope you print up your the one that. Sorry, Casey, for give. And who was the other one? I know I give 2 students wrong notes. Okay.
Yeah, I did print it out and I just took the pages that I needed.
Okay. Yep. All right. Next is this. So this is step number 4. So step number 4 is doing all this, and usually this is all done using your StatCrunch. There's no formulas here, using StatCrunch. And now we're gonna talk about your decision making. Okay, this is very important. So step 5 is this decision making. So if your p-value is less than alpha, we will reject the null hypothesis. If your p-value is greater than alpha, we will fail to reject the null hypothesis. So we have to look at the p-value, which is found in here, the one that the one I highlight in blue, and the alpha. Alpha usually is given in the question, 0.05, even 5%. So if this alpha that you found is less than or equals to alpha, p-value that you found is less than or equals to alpha, we will reject the null. Otherwise, we will fail to reject it. So, so this is what we call as your decision. This is number 5. And this has nothing, the less than or equals to or greater than has nothing to do with your alternative hypothesis. Okay? A lot of students think that this hypothesis statements, less than or greater than, has something to do with this, this symbol. No, this is based on alligators. You guys remember how you guys do, which is less than, which the alligator mouth eats something? So it's very similar to that way. So we can do that on here. So now we are doing what we call as a decision. So the decision is based on alpha is 0.05. So you can look at your p-value in this case. My p-value in this case, so we'll talk about decision here. So decision. So our p-value is given as we found is 0.0228. And our alpha, that little fish with quite significant level, is 0.05. So can someone tell me, is 0.0228 is less than 0.05 or greater than? Which one? Is 0.0228 is less than or greater than alpha?
Less than.
Awesome.
Less than. So which is less than symbol? Is that the first symbol or the second symbol?
First.
Okay, so this is the first symbol. So again, this decision has nothing to do with that greater symbol. So do not just look at the greater and put, no, this is based on the p-value and the alpha that we have. So if your p-value is less than alpha, your decision will be, we will reject the null hypothesis. So if p-value is less than alpha, the decision here will be, we will reject H0. Okay. Otherwise, we fail to reject. So the decision making is based on the p-value and the alpha. This is quite important, so make sure you guys know the decision making here. Same thing happens on question 4. So first thing first, we had to figure out, is this two tail, left tail, or right tail? And how do you know which one is which? So last time the claim statement is right here. I say this is a right tail. So can someone tell me where's the claim statement in this case? On question 4.
What would I say is two tail?
So because this is not, this is a claim
Not
statement.
equal to. It's not equal to.
So it's not equal to, so this is going to be a two-tail test. Okay. So this is a two-tail test. Is this proportion or is this mean?
Proportion.
This is proportion. And why is proportion?
Because of the P.
Because of the P, you're correct. So because of the P, it is proportion. Okay. So if it's mu, mean. Now we need to find the critical value because the question asks us to find the critical value. Since it is proportion, are we using normal calculator or are we using T calculator? Normal or T calculator? So since we are using proportion, we use a normal calculator, and you say it's a two-tail test. So let's go up to that table again. So this is a table. We are using proportion. That's why using normal calculators. So this is a two-tail test because we use a not equal symbol. So in this case, we have to use px greater than or equals to blank, alpha over equals to alpha over 2. So this is your critical value. So your critical value is where you take p, x is greater than or equals to blank. Blank is where your answer is. This is equals to alpha over 2. And alpha in this case is 0.05. So you can use your StatCruncher. So you go to your normal calculator, which is this one. We still use 0 and 1, always 0 and 1. X greater than or equals to blank. Make this blank, and you make this as alpha over 2 because our alpha in this case is 5%, and this number is 1.96. Okay. However, if you give me 1.96 here, you will get it wrong Why this is wrong is this is not two tail. So this is only one tail. So the correct answer in this case will be class minus 1.96. That means that you will have two tail. One is on that side and the other one on the left side. And both of these giving you the same answer. But one of them is positive, the other one is negative. In your online homework, they don't like plus minuses, so you have to write your answer too, like 1.96 and negative 1.96. Yes, Casey.
So that the significant level where it says 0.05, we're always going to be given that, right? Because I was
Yes.
trying to figure out
Yes, it's
why
right
you
here.
chose the 0.05.
Yeah.
Okay.
It's always given. And it can be
Okay.
10, it can be 20, it can be 1%, 0.01. It's always given to you.
Okay.
You just need to find it or search for it.
Okay.
So this is how you find your critical value. Now we need to find the p-value, so the blue one. So we're still gonna use normal calculator because proportion. So if you look at the second table from this is the table that we have. We are doing proportion and we are using two-tailed test because it's not equals to. So it's p greater than equals to z-score, and z-score is given in the question. And you have to do what? You have to double it. Don't forget, once you get your answer, take out your calculator and double it because you will have two-sided. So in this case, we will use normal calculator here. We will use p x greater than or equals to your z-score. What is your z-score in this case? Is given to us by what? 2.5. Okay, so this is the z-score in this case, which is 2.5. Okay, and this blank will be your answer in this case, your p-value. So we're gonna do something different now. So 0 and 1, we still greater than or equals to 2.5, and we're gonna make this blank. So this p-value is very small, but you have to double it. So this p-value that we have found here, using your StatCrunch, is 0.00621. 0.0621. 0.00621. Okay, but make sure that you have to times 2. The reason why you need to double it is because if you look at your area, is only one side. You told me this is a two-tailed test, so the other side have exactly the same value. So this means this is also 0.0062.
Excuse me, where did you get it? 0.0621.
1. Yep. This
Where
one
did you get it from?
right here,
Oh, okay. Thank you.
the blank.
Okay, thank you.
And you need to double
So I
it
have a
because
question.
it's the same. Yes.
So we're using this because it's specifically telling us the z-score. If it tells us the t-score, then we use the same thing except go to the t calculator.
Yes. Yes. You're
Or-
correct. Yep. Anyone has
Sorry,
a
this is way.
Nope, you're fine. So you take 0.00621 times 2, because we need to double this. It's a two-tailed test. So that came out to be 0.012, this one. So this is your answer here. 0.1242. Whoop, forget the 0. Okay, yep. And usually if I give you T, I don't use P, I will use the mean, Okay, don't forget mu, the mean, we use T. Proportion P, we use a Z. So the p-value in this case is double of this. Now we have to make the decision. So the decision is based on this p-value that you have. P-value in this case you get is 0.1. 0.01242, watch out for the. And the alpha that we have, which given to us. So all this is either given or found in 0.05. So can someone tell me, is this 0.01242 is less than or greater than? Which one is the correct symbol? 0.01242 is less than or greater than? This should be
Would it be less than?
less than, right? Because this number is less than that number. This is only 1%, okay, 1.2%. So if this is less than, what is the decision? Do we reject or do we fail to reject? We will rejecting the null hypothesis. Okay. So the only time that you fail to reject is when this p-value is greater than alpha. Okay. So this is how we make decision. It's based on the p-value that you found here and the alpha given to us, and figure out, are they less than or are they greater than? So let's do this again in number 5. So this question wants us for decision. So the decision is based on alpha and the p-value. So p-value first. Now, sometimes the question you have to find the p-value like what we did here. And sometimes the question provide you the p-value, which is right here. So the p-value given to us in this case is 0.0010. And the alpha is given us by 0.05. So can someone tell me, same thing, which one are we using? Is the p-value 0.0010 is less than or greater than 0.05 for your alpha?
It's less than.
So less than, so the decision is what? Do you reject or fail to reject? We will be rejecting now. So you find out that majority of them, the p-value is less than alpha, but it's not always that case. Okay, so you can have a p-value that is greater than alpha, then you will fail to reject H0. Okay, so this is the decision that we have. Now we're going to go to a very difficult one. I'm going to underline the claim statement. So when you guys do this in my test or in my homework, if you can underline, please do underline or highlight this. So that is the claim statement. So if you're talking about the percentage of blue M&M is greater than 5%. So that is the claim that we have. So what we're going to do is we got decision. Now we do the conclusion. So this is the last step we're going to talk about. So step 5 is a decision. The step 6 is a conclusion. So this is the third table. So this table is the most important table for all. So when you guys, I would recommend you guys, if you guys need to put this in your the cheat sheet that you guys can bring, number 5 and number 6 is what you need to do. Okay. So depends on there are 4 conclusions you can make. 1, 2, 3, 4. Okay, and these 4 conclusions depends on 2 things. Either your claim has it does not have equality, or it has equality. It includes. So depends. So 1, look at your original claim. Original claim is a claim that is given originally. Like, does it has an equal sign on it, or the word equal? Or it has the word not include equal. Not include equal means less than, greater than, and so on. And you also look for your decision. If you reject your null hypothesis, you are making the first conclusion. If you fail to reject the null hypothesis, you are making the second conclusion. If you reject the null hypothesis, you will make your original claim includes equality. You are doing the third conclusion, and the last one is if your claim has equality but you fail to reject, then you make the 4th decisions. So this is based on 2 things: your claim statement and your decision. Okay. And your conclusion says, the first one says there is sufficient evidence to support. So support means that means you're supporting the claim, means good. The second conclusion is there is not evidence to support, means you're rejecting your claim. Okay. The next one is there is sufficient to reject the claim. So this is also, so number 2 and number 3 are kind of the same because both of these are you're rejecting the claim. And the last one is that is not sufficient evidence to reject the claim. So this is like double negation. So so 2 negative become positive. So this the fourth conclusion that you make is actually you are supporting the claim. Okay, so they use the double negation here, the word not and the word rejection. So they are supporting the claim. So there are actually 4 ways of your conclusion here. This means yes, they support your claim. This means no, you're not supporting your claim. This one also means no. The word reject means no, you're not supporting your claim. This one has 2 no words or 2 negation words. This means yes, it is supporting the claim. But the way they write it is this way. The reason why I'm doing this way is because your online homework is using this way, and I'm also using this way when you do my test and my work. So so we, as you know, that we don't use the word accept. The reason why we don't use the word accept, we use the word fail to reject, is because we still have that 5% error. So when you use the word accept means that you are 100% accepting. Okay, it sounds like 100%. So we are not actually 100%. We are, if you have 5% error, we've got the 95% chance, right? So we use the fail to reject. Yes, Lawrence.
Bro, why is that use statisticians make things difficult?
I'm sorry.
I said use statisticians make things difficult.
No, this is usually what we do. This is how we do it.
I was going to say why don't we use the word accept?
Because we have accept means it's a very strong word for you're 100% accepting, and we are not 100% confident accepting it. We are only 95 or 98. So we use the word fail to reject. So never use the word accept.
Okay, thank you.
Yep. So we because of the error that we can make. And watch out for multiple negative, like the word not and the word reject, they are negative. So if you have double negation, it become a positive. Okay. And so what do we do here, class, is make sure you know what is your claim statements and what is your decision. So this is how we're going to make conclusion here, because this question is asking us for conclusion. So in order for us to make a conclusion in this case, you need to watch out for 2 things. So conclusion. So first thing is your claim statement. So if you read the claim statement that I highlight in yellow, does your claim statement has equality or no equality? It says the original claim, the M&Ms is what? Greater, right? So this claim statement has no equality. When it has equality, then it is a 2-tailed test. Okay, when it's equality, it is a 2-tailed test. Okay, greater than is a right-tailed test, so it's no equality. Okay, so no equality is where it is less than, greater than, or not equals to. Okay. If it's equality, means exactly equal. So your claim statement has the word equal to. Okay. So it has no equality. Your claim statement has no equality. And then if you look at your decision says you are rejecting the null hypothesis. So what happened is now you got no equality and reject the null hypothesis. So now if you refer back to the table we have here, so we have not include equality and you reject the null hypothesis. So actually this is the first conclusion you make, okay? Because your claim statement doesn't have equality and you reject your null hypothesis. So your conclusion is there is sufficient evidence to support the claim that now this is your original claim. So this is how we write your conclusion out. So your conclusion in this case is there is sufficient evidence to support the claim. And then you see the word dot, 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 dot behind. The dot, dot, dot one is the original claim. And this is the original claim. So don't use dot, 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 that the claim, support the claim, that the percentage. So you have to actually write it out of blue M&M. So the one that I highlight in, or in yellow is your original claim, greater than 5%. So you actually have to copy this and paste it. So in your test, you cannot just be lazy and do the dot, 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 and then draw me an arrow and say, oh, this is my claim. I will take 1 point off in your test by doing that. So make sure you write these claim statements down here. So you see all the tables here, they got the original claim. This original claim is copy and paste from the original claim given in the question. You actually have to write it out literally. Okay, so this is how you do your conclusion based on your decision here and based on your claim statement. Yes, this is difficult, and this is the first time you guys see it, and we'll be using this this table for chapter 8, chapter 9, and chapter 10. So the last 3 chapters, we are using this. So this table is super, super important. Okay, I'm going to take attendance. So go to the chat room and type present. Okay. And the last thing we're going to talk about here is how we answer the question. So the answering the question is very easy. The answer in this case is based on your conclusion. If you support the claim, then your conclusion will be valid, or yes, or will be true. Okay. So valid, true, yes, because you are supporting the claim, so that means your claim is true or your claim is valid. If you do the second conclusion, because you are not supporting the claim, so your claim in this case is either invalid or it is false or it is wrong or something else. Okay, this one is also invalid or false or reject or wrong because of the word rejection. And if for the last one, if you make the last conclusion, you have the word not and the word reject, this conclusion or this will be valid. Your statement will be, your claim statement will be valid or is true. So if your conclusion is number 1 and number 4, your answer will be true or valid or yes. If your conclusion is number 2 or number 3, is invalid, false, or reject, or not true, something like that. So this is how we answer the questions. Usually this is used a lot in 8.2 and 8.3, where they want you to answer certain questions. And the question is usually asked, is the claim statement, original claim statement valid or invalid? And how do you know it's valid or invalid? It depends on the conclusion you made here. Yeah, this is super tough. I didn't say this is easy. Okay, so the type 1 and type 2 error, I want you guys to just read it yourself because I think you guys can figure out their own. But I'm going to go through some examples in your StatCrunch so you guys can see how do I make this decision and everything. So I'm going to show it to you. So this is where they ask you to make decision and then make conclusion. I think that's almost towards the end here. No, this is type 1, type 2 error. Please read through type 1 and type 2 error because that is not too difficult. The difficult part is this. This is the one that usually I wouldn't ask you type 1, type 2 error, but just in the test I wouldn't ask for that. But I will ask you for this one, the decision and the conclusion. So read this question. It's given us that this is your original claim. And the hypothesis, the p-value is this, and the alpha is 0.01. So that is your claim statement. So how do we answer your decision piece? So this is number 9, question 8.1, question 9. So first thing first, you figure out the question give you the p-value, right? And the question give you alpha. Can someone tell me what is a p-value in this question number 9? P-value
Yeah,
is
it's
what?
0.0628.
6.0. Yep, that is a p-value 0.0628. And what is alpha in this case?
0.1.
0.1, which is up here. So my question is this p-value is less than or greater than alpha? Which one?
It is less than alpha.
So p-value here is less than alpha. And what do we say when p-value is less than alpha? We reject or we fail to reject H0. We will reject, right?
Reject.
P-value is less than alpha, we will reject. Now, class, a lot of students in my test, they just write reject. You won't get full points in your test. You have to write reject H0 because you can reject H1, the alternative HA. So make sure that you write the word reject H0. So without the H0, I will take some points off in your test. So which one is the correct answer in this case? Is that A, B, C, or D? What is your decision?
Wouldn't it be B? No,
failed?
never mind. It's not fail to reject. That's not correct. Wouldn't it be C? Reject HO because the p-value is less
P-value is,
than.
yep, that's correct.
Yeah.
So you reject because the p-value is less than alpha. All right, now we need to figure out your conclusion. The conclusion is that table we mentioned about. So in order for us to do your conclusion here, first read the original claim statement. Do your claim statement has equality or no equality? Which one? This is your claim statement.
It doesn't have equality.
The word is, anyone know what is the meaning of word is in math?
Oh, so it's equal.
Yes. So don't forget, in math, the word is means what? Equal. Yep. So make sure you. So
I
they
thought
are
it was
very.
going to say equal.
Yep. So
the
it has the word
itself.
equal, and sometimes they use the word is.
Okay.
So is means equal. That is your. So it have equality, and you are rejecting H0, right? This is from what? From your decision on top, right? So now look at your table. Can you tell me which conclusion are we making here? It says that your claim has equality, includes equality, and you reject H0. Is that number 1, number 2, number 3, or number 4?
So it's going to say there is sufficient evidence to warrant rejection of the claim.
So it's number 3, right? Yep. So
Yeah.
this is number 3 because the original claim has equality and you reject the null hypothesis based on the p-value and the alpha. So your answer in this case is there is sufficient evidence to warrant this one, the third one. So which one is the correct answer, A, B, C?
Oh, I can't see it.
That's right.
I think A is it.
Here.
A.
So it will be A. There is sufficient evidence to warrant rejection of the claim. And what is the claim? The mean pulse rate of a certain group adults is 68 beats per minute. So your answer in this case will be A. Yep. So this is how you use this table 1, 2, 3, 4 to figure out which is the correct way to do it.
Hey, Prof.
I'm sorry.
Professor Liu,
Yep.
can you hear me? Do
Yeah,
you
I can
think
hear you.
do you think the textbook would explain further?
It's the same thing actually.
Okay, so you
You
mean we
can-
should go read the textbook
Yep.
too?
And the only thing that is textbook is different is they to find the critical value and p-value, they don't use StatCrunch.
StatCrunch.
They
Okay.
don't use. They use the tables.
Okay.
They
Okay.
use the Hoiki tables. So do not use that. They will use, the table. Some of you seen it before, like this table. See that? They will use this table.
Yeah.
So I would recommend you to read the textbook. Once you to find the critical value or p-value, they will use a table, but you use the StatCrunch to calculate it. Your answer should be the same.
Okay. Okay.
But the making decision and the conclusion here, they are exactly the same. It's fixed. This is fixed. This decision and conclusions are fixed. That means it's the same throughout the whole chapter.
Okay. Thank you.
So I would recommend you guys to practice this, especially these two, the 5 and 6. This is the main part of the stuff. The type 1 and type 2 error, I also recommend you to read through the book. It's not going to come up in your test at all, but it will be in your online homework. They're all mostly multiple choice. So don't worry more about type 1 and type 2 error. I'm worried more about this one, the decision and the conclusion. I will definitely will go over this together on Wednesday in class. So make sure you guys start working on your homework. Your 2 homework due on Wednesday, which is 7.2 and 8.1. 7.2 is not too difficult. 8.1, it's a little bit there. So I would recommend you to spend some time on it and also read the books. If you do not want to read the books, I will recommend you to watch the videos. Remember, in detail, I post you some videos for chapter 8.1. I don't know how many of you watched that YouTube videos from the beginning of the semester. So I would really, really highly suggest you to watch that video. So if you go to, I think I reposted that already from last week. So this is the 8.1 video. So there are 2 parts here. So I would recommend you to watch this YouTube video here. If you doesn't know how to, the first part usually is the first 3 steps. If you need to go through the last 2 steps, the decision and the conclusion, I would recommend you to watch part B of this YouTube video, and also type 1, type 2 error. They will teach you how to, it's only one, so short. Oh no, this is advertisement. So I would recommend you to watch this one. So they will tell you I would highly recommend, if you do want to read, then I would recommend you to watch this video. And again, this video will show you the long way to find the critical value, not using the StatCrunch. They will use that table. So please ignore it. Okay, so please watch the video in this case. Right. Anyone have any questions for me before we end our Zoom class here? If you do